So why is maintenance such a challenge? Well, some of the factors that affect the maintainability of software are listed here. The first one, availability of qualified staff. Think about this. Who are the people that most organizations will assign to maintenance? Here's a typical scenario. We just hire this guy, Fred, and say, well, we don't have any place to put Fred right now, where he can't do a lot of damage. So let us put him over here in maintenance and let him learn the product, okay, by putting him on maintenance. Then when he proves himself on maintenance, then we can assign him to a real job, which is software development. A lot of times the maintainability and maintenance is sort of viewed as a sort of a learning step, like a place where we put people to let them learn the product, and before we turn them loose on real development. Or conversely, this guy's been around for 40 years and he's no like a COBOL programmer. You say, well, we can't assign this person to real software development. Let's put him someplace where he can't do a lot of damage. Let's put him on maintenance. Now that's not true everywhere, obviously, but that tends to be sort of a theme that we see. So the qualified staff for maintenance. Maintenance is not viewed as a desirable career path, a desirable thing to be working on. We have to change that, I think. We have to change the perception of maintenance as something that is actually a good thing. Because I said maintenance is a good thing, and maintenance should be considered a desirable job, as good as useful as programmers and designers and other people. Okay? It's valuable. As a matter of fact, if you look at where the budgets are going, right, all the money is going to maintenance, and so we should put our qualified staff on maintenance because that's where the expense is. In order to reduce the expense, we ought to put qualified people on maintenance so they can do a better job and be more efficient. Understandable system structure, right? We pointed this out before. The fact that that maintenance is so expensive is due to the fact that we did a real crummy job when we wrote the software in the first place. There is no design, there is no documentation worth anything. The structure is so convoluted that it's very hard to make changes without causing all sorts of ripple effects. Use of standardized programming language. This could simplify, and operating systems, these could simplify maintainability an awful lot. This is the main reason why, for example, the Department of Defense about 20 years ago started going to standardized languages in operating systems. You really have to get a waiver in order to use a language other than the approved small set of approved programming languages and operating systems for your software. And that the reason for having the standardized languages is therefore your maintainers don't need to learn all sorts of languages. Back in the old days, where the Department of Defense had all sorts of programs written in all sorts of languages, they'd have the people in the military that had to maintain these programs, they'd have to send them to language school for, they have the person like 4 years, right? An enlisted person is available for 4 years, and they have to spend 2 of their years learning the programming languages, and therefore they only get like half of the amount of time of those people to actually do actual maintenance. Standardized structure of documentation. Well, first of all, is there documentation? I mean, no lack of documentation is a serious problem with the maintainability of software. So assuming you have documentation, it would be helpful if there was a standardized structure for that documentation so that the maintainers could read the documentation and understand it. The only thing that's worse than no documentation, I would say, is documentation that is wrong. And I can't trust the documentation. If the maintainers find that the documentation is old and doesn't correctly reflect the software that they're trying to maintain, they're going to throw the documentation away. Availability of test cases. A lot of times when we develop software, we test the software. We have to develop all these test cases. But then when we ship the software, we don't ship the test cases. And so that we kept, basically they get thrown away because somebody else is doing the maintenance. It would be very helpful if the maintainers also had the test suites so that, for example, when they change things, they can do the regression testing. Built-in debugging facilities. A lot of times also when we build our software, we put debugging facilities into the code in order to debug it. once it's, quote, debugged, once we ship the software, we remove all that stuff. Right? And so the maintainers have to put those things in, themselves. It would be nice if we had these debugging features built into the software, and you'd be able to turn them on and off with a switch. And a proper computer to conduct maintenance. I'm not sure how prevalent this is anymore, but at one time, from my experience, we were building military software that ran on military computers. And in one case, I recall, they wanted to modify the program that was running in a computer that was part of an aircraft. And they didn't have any computers of that type on the ground to test the software. So they actually had to land one of these aircraft, put it into a hangar, and they could run the software on the computer in that aircraft. So they have a multi-million-dollar aircraft sitting there, so that they can test and out of service basically, so they could test the software on the computer in that aircraft. Some problems with maintenance, somebody else's program, right? So I've got stuck with maintaining somebody else's program. I don't know the person. I might see a name and a phone number in the listing. And so I'll call up the phone number and I say, hey, is Sally there? She wrote the software. And they say, Sally? Sally who? Oh, Sally. Yeah, she left the company 3 years ago. And so the person that wrote the software, even if you knew who they were, they're not available, so you can't talk to them. Or they don't remember, and things like that. The documentation doesn't exist. And as I said, the only thing worse than no documentation is improper, incorrect documentation. The program was thrown together, and with all of the shortcuts that they took to get the software out the door in the first place, they didn't do a very careful job of designing the software or documenting the software, and its structure is so convoluted that it's not easy to make changes to the software. You get a lot of ripple effects. If you change one thing, lots of other things break. And as I pointed out before, maintenance is not always a highly regarded activity in a company or an organization. All right, so what can we do? We got some changes to make to the software, right? And these changes keep coming in, right? Change never stops. We could continue piecemeal modifications. Sometimes when we're modifying things, we have to, got these ripple effects. We just put little band-aids over the ripple effects, and it reaches a point, though, as we continue making these little teeny tiny changes, these incremental modifications to the software. Every time we make a change, the structure of the software gets a little bit weaker, the internal structure. And eventually, it's going to reach a point where the internal structure is going to break. The software gets more and more brittle, and it's easier to break it, right? Easier to make some change, and the whole thing falls apart. So you can continue the piecemeal modifications only so long. Eventually, you're going to reach a point where it's impossible to, well, it's not impossible, but it gets more and more expensive to make these little incremental changes all the time, because not only do you have to make change to the thing that the request came in for, but because of the ripple effects, you've got to change lots of other things. And the longer you go, the more ripple effects you get. So you have to change a lot more things. Sometimes we actually deliver software with known defects in it because it's prohibitive cost-wise to chase down all the ripple effects that would be caused by modifying the software. And so we'll ship the software with known defects, and we document those, like workarounds. Say, well, we know this part of the software doesn't work exactly right, but we found a way to avoid having that problem. Sometimes we're going to have to bite the bullet and redesign and recode and retest the parts of the software, or in fact the entire program in some cases. This has been done a number of times on really major programs. IBM has a tool called CICS, big, major product of IBM. About 20 years ago now, they actually had to bite the bullet and rewrite that because a lot of people, a lot of programmers and maintainers were bypassing all of the structure, and the program would keep getting more and more brittle as they would maintain the program. Eventually they said, well, in order to make any more changes in a cost-effective way, we have to rewrite this. Microsoft with Visual Basic. Visual Basic, I think, was version 6 is the new platform. The old Visual Basic, they just basically threw away the old program and rewrote it using this new platform. And so thus extending the lifetime of these products many, many years. Right? If you don't do this, if you don't redesign after a certain point, you're limiting the lifetime, the effective lifetime of being able to maintain this product. By redesigning, you're extending the lifetime 20, 30 years. Just a few things to give you food for thought. The cost to maintain one line of source code or one line of code may be many times the cost of the initial development. We pointed that out before in our ROI discussion. Figure it takes somewhere around 2 to 4 times the cost to maintain the line of code than it did to build it. Barry Bain gave us that figure 40 times. I'm not sure how much I believe that, but somewhere the truth lies there, somewhere in between the 2 times and 40 times the cost. So that gives us the leverage to do extra things when we build the software to promote better return on investment, to promote easier maintenance later on. If we redesign the software architecture using modern concepts, such as things we've talked about in this class, that will facilitate maintenance in the future. Another thing is, if I have to rewrite the software, it's not a complete life cycle because I already have the requirements for the software. I already have a lot of analysis and design done, and I just need to modify things about the design. Basically redesign and recode to the existing architecture and the existing requirements. Maybe the architecture needs to be changed, but the requirements are the same. Because basically you can use the existing software as a prototype for the new version. I don't recall where I got these points about maintaining old code. I thought they came from Roger Pressman, but I'm not entirely sure. But here are some points, some tips for how you might go about maintaining existing code. Before you get into emergency mode, you may want to just review the program, do your own documentation. If you can, do like flow charts and activity diagrams and class diagrams and so forth. So try to become familiar with the whole structure of the program before you get into this emergency mode. You might examine any existing documentation to see if it is correct and if it needs to be modified. Put your own comments in the source listings if they'll help. Basically, you want to treat the source code as sort of golden. You don't want to delete any lines of source code. Don't delete lines of code. But if you add lines of code or you modify lines of code, actually put a lot of comments in there around all of this to make it clear what the audit trail is for the changes. So if you add lines of code, carefully document the lines of code that you added by putting comments in the code to say these lines were added and the date they were added and the name of the person who added them and the reason you added them. If you want to remove code, don't delete the lines, just comment them out and put comments around the commented out code to indicate why you are deleting those, essentially deleting those lines by commenting them out. Okay. And don't eliminate the code, don't comment it out unless you're sure that it's going to be safe to do that. This thing about temporary variables, we still have the problem with variables being shared by multiple pieces of the program. It's kind of ridiculous now because back in the old days, memory space was expensive, but now memory is so cheap. You should never reuse the variable. A variable that you use for one thing, you should never reuse that for another purpose in your program. Keep detailed records of maintenance activities in the code and perhaps outside of code as well. Keep logs of what you changed. And so that you can always go back at some point and see all the changes that were made and why you made the changes. Sometimes we have this irrational urge to throw out the program and completely rewrite it. You want to resist that as much as you can because it's a big effort to completely rewrite something. And so usually we can salvage the program. However, sometimes, the note says here, so sometimes it's both rational and practical to throw. It depends on whether it's a real piece of garbage or not. Um, insert error checking. Okay, if the programmer didn't leave that in the code in the first place, you ought to put your own error checking and your own debug facilities in the code for maintenance purposes, and keep them in there. Okay, so that's our discussion of maintainability.